Alright, welcome to the lunchtime video for the JNCIE-SP. Let's get started. Okay, so we're still going to be discussing high availability techniques, but we're moving on from link and node protection onto LDP protection. So this is going to be quite a bit different because before we were dealing with RSVP. Okay, so let's get the title ready for the video. Oops, and I can change the name of this if it will allow me to. There we go. Okay, so no longer going to be link and node protection. It's going to be LDP protection. Perfect. So this is the first video. Let's do a Google search right away. Yeah. So I think this is the knob they're talking about, is this session protection. Looks like, yeah, so when an LDP session is torn down and re-signaled after the router stops receiving hello messages from a neighboring router, you might want to modify this behavior to prevent an LDP session from being unnecessarily terminated and reestablished. The LDP session remains up for the duration specified as long as the routers maintain IP network connectivity. So it looks like we got a nice example here. We've got lots of routers. I guess I'm surprised there's no configuration given. Here's the example. Okay, yeah, so let's try to wire this up. Yeah, so this is going to be configuring LDP link protection. So LDP link protection enables fast reroutes of traffic carried over LDP LSPs. In case of a link failure, LDP point-to-multipoint LSPs can be used to send traffic from a single route or ingress node to a number of leaf nodes or egress nodes, traversing one or more transit nodes. When one of the links of the point-to-multipoint tree fails, the subtrees can get detached until the IGP reconverges and multicast LDP initiates label mapping using the best path from the downstream router to the new upstream router. To protect the traffic in the event of a link failure, you can configure an explicit tunnel so that the traffic can be rerouted using the tunnel. Junos OS supports make-before-break capabilities to ensure minimum packet loss when attempting to signal a new LSP path before tearing down the old LSP path. This feature also adds targeted LDP support for multicast LDP link protection. When configuring LDP link protection, be aware of the following considerations. Configure traffic engineering under IGP if it is not supported by default, and include the interfaces configured for MPLS and RSVP so that the constrained-based link protection dynamic RSVP LSP is signaled by RSVP using constrained shortest path first, CSPF. When this condition is not satisfied, RSVP LSP might not come up and LDP cannot use it as a protected next hop. So I'm getting really confused because I thought RSVP was an alternative to LDP, but it looks like they're using them concurrently, which is confusing to me because I would think that if you're using LDP, you wouldn't need to use RSVP. Configure a path between two label switch routers, LSRs, to provide IP connectivity between the routers when there is a link failure. This enables CSPF to calculate an alternate path for link protection. When the connectivity between the routers is lost, the LDP targeted adjacency does not come up and dynamic RSVP LSP cannot be signaled, resulting in no protection for the LDP forwarding equivalence class, FEC, for which the peer is the downstream LSR. If link protection is active only on one LSR, then the other LSR should not be configured with the strict targeted hellos statement. This enables the LSR without link protection to allow asymmetric remote neighbor discovery and send periodic targeted hellos to the LSR that initiated the remote neighbor. When this condition is not satisfied, LDP targeted adjacency is not formed. LDP must be enabled on the loopback interface of the LSR to create remote neighbors based on LDP tunneling, LDP-based virtual private LAN service, VPLS, layer 2 networks, or LDP session protection. When this condition is not satisfied, LDP targeted adjacency is not formed. For unicast LDP LSP, loop-free alternate LFA should be configured in IGP. The ingress route to merge point should have at least one next hop, avoiding the primary link between the merge point and the point of local repair for unicast LDP LSP. Point of local repair should have a unicast LDP label for the backup next hop to reach the merge point. Okay, so in this example, R5 is the route connecting to two leaf nodes, routers R3 and R4. Router R0 is the point of local repair. Alright, so let's cable it up. Okay, so we got 1, 2, 3, 4, 5, 6 routers. Here we've got 1, 2, 3, 4, 5, 6. So let's get rid of the extra ones. So they're going to have 0, 1, 2, 3, 4, and 5. So we'll use 10 as 0. So 0, 1, 2. Oh, but we're missing a 3. So let's just keep, yeah, so let's get rid of these links. Okay, and then keep the ones, so this will be the first and the last one. Then we're also going to have rudder 2. This one we can get rid of. Okay, and then we've got 2. Okay, so, and then 1. So, yep, they stop at 5, and it looks like I'm missing a 3, so I'm just going to rename 6 to 5, and then I'll delete R7. Okay, so this will be, oh, it's not going to be renamed to 5, it's going to be renamed to router 3. Alright, so that looks good. So let's arrange it the way... Oh, I'm not sure what these are. Okay, I don't think it matters. Okay, so yep, now let's arrange this. So R3 would be on the very end, and then R4, R1, okay, R2 and R0. I'm going to use R10 for R0. Alright, and then R5 is the root. And then these are the leafs, and then these aren't considered in that topology because they're just transit routers for the MPLS connections. Okay, so let's cable them up next. 0 to 0. Okay, it looks like there's a port channel here, but here goes 0 to 1. Oh, no. It's just this link here. Yeah, it's kind of strange, but it's 1 to 1. Oops. Okay, and then 0 to 0. Alright, and then 2 to 2. Alright, and then 1 to 1. Alright, and 3 to 3. Perfect. Okay, so next is the configuration. We'll start with router 5. Alright, so the first configuration we'll add back in is just the base config. Alright, and then we'll type out this router 5, and I'll need to take a quick break after that. Yeah, this is what I find interesting, that RSVP is enabled, because I thought you didn't need that. Okay, so here's the key command that we're learning about. It's link protection. So enable link protection to protect interface for link faults only. You can also, I think, do link and node protection. Well, I don't see that. I thought you could, well, okay. So that's the only option we have. We don't have the option to enable it for things that are not only link protection. I don't see any other option besides only doing it for link protection. But we do have some knobs at the end. We can disable link protection. I don't know why you would include the... Yeah, that's just kind of a strange command. But the one we're going to go with is dynamic RSVP over LSP, enable setup of dynamic RSVP LSP for link protection. Oh, I see. I think that's why we're enabling RSVP alongside LDP, is because we're using RSVP to form our link protection. So basically what we're doing is we're saying, okay, LDP, you're good to go. You can automatically create a LSP for us, but if anything happens and that LSP were to fail, fall back to this static LSP, and we know from before you can only create static LSPs using RSVP, so that's why both are required to be enabled. Okay, so now we're going to advertise P2MP capability to peers. Alright, so this is the extent of the configuration. I am curious about P2MP and dynamic RSVP over LSP, see if I can get some more information about that. So I'm going to do help apropos dot pipe match, and then it's going to begin with HELP and also topic for good measure, and then pipe match. We'll start with P2MP. I think that's going to be a bit easier to find. So we've got all sorts of information about that. Yeah, let's look at some examples. So point to multipoint LSP based on the topology. So yep, it's point to multipoint signaling. So yep, and that's exactly what we're going to have. You see we have a letter Y here with the root here and the two leaves. So this is going to be a point to multipoint LSP. Yeah, so we're going to have, oh, I'm surprised that there's no, oh, but it's going to be built using LDP instead of RSVP, so we won't have these. We're going to have an automatic point to multipoint LSP. Okay, so let's see if we can get some help information on this other knob here. I'm a little bit unsatisfied with the help I got for P2MP. I think I'm just going to look at one more. So yeah, let's look at primary here. So point to multipoint LSP must have a configured primary point to multipoint LSP to carry traffic from the ingress router. The configuration of a primary point to multipoint LSP is similar to a signaled LSP. Okay. Yeah, I feel a little bit high and dry with that, but let's just move on. Okay. Oh, didn't get anything for that. Let's get rid of this topic here. See if we get anything. Nothing still. Alright, so let's go back and let's just search for dynamic. This looks interesting. So by default, the branch LSP for point to multipoint LSP is signaled dynamically using CSPF and requires no configuration. When a point to multipoint LSP is changed, either by the addition or deletion of new destinations or by the recalculation of the path to existing destinations, certain nodes in the tree might receive data from more than one incoming interface. This can happen under the following conditions. Some of the branch LSPs to destinations are statically configured and might intersect with statically or dynamically calculated paths to other destinations. When a dynamically calculated path for a branch LSP results in a change of incoming interface for one of the nodes in the network, the other path is not immediately torn down after the new one has been signaled. This ensures that any data in transit relying on the older path can reach its destination. However, network traffic can potentially use either path to reach the destination. A faulty router at the ingress calculates the paths to two different branch destinations such that a different incoming interface is chosen for these branch LSPs on a router node common to those branch LSPs. Alright, so I'm going to take a quick break. I'll be right back. Okay, so we've got a red circle again, so we're recording. I finished reading all this, so let's just continue to configure the rest of the routers. So router 0, I'm just using router 10. But I can name it router 0 if I choose. Perfect. So the next step is going to be, so I already did the delete. So if I do a show pipe display set and take a look at my candidate configuration, I've just got that base config on there. So let's add the rest of the config. So it looks like I accidentally added 2 IP addresses to this interface. Let's take a look at my configuration. Okay, everything looks good. Okay, so on to the next interface. Perfect. So on to the next one, and I think I am gonna go ahead and change the hostname on it. It's really not that difficult, especially when everything else in the topology is so cleanly named. Oops, but I gotta make sure to single select. Okay, so on to router 1, which is going to be, yeah, I'm surprised they picked that order, but it looks like they're going to move ahead to this one and then come back to that one. Oh. Alright, now we're going to go back to an earlier device in the topology if we're just looking at the devices straight as they come left to right, and configure router 2. Oh, now this is interesting. Enabling traffic engineering under MPLS. I'm actually not sure when that is necessary and when it is not. Um, Perfect. So we got, oops. Oh, right, because I deleted what was on there already, so we're going to see some configuration removed. But this should look good. It should look better after I commit it and take a look at the active configuration. Okay. So, yep, that looks pretty good. I've got traffic engineering included for both the OSPF and MPLS protocol. I'm curious about its usage under the MPLS protocol, so I'm going to do a help apropos, pipe match, help topic, pipe match, traffic engineering. Okay, so let's see what the help has to say. When you configure an LSP, a host route, a 32-bit mask is installed in the ingress router toward the egress router. The address of the host route is the destination address of the LSP. Typically, you configure the BGP option, traffic engineering BGP, allowing only BGP to use LSPs in its route calculations. The other traffic engineering statement options allow you to alter this behavior in the master instance. This functionality is not available for specific routing instances. Also, you can enable only one of the traffic engineering statement options at a time. Enabling or disabling any of the traffic engineering statement options causes all the MPLS routes to be removed and then reinserted into the routing tables. You can configure OSPF and traffic engineering to advertise the LSP metric in summary link state advertisements, LSAs, as described in the section advertising the LSP metric in summary LSAs. Okay, so that looks good. Yeah, router 2 is now complete, so let's move on to router 3. Hopefully I can get this done before the lunch hour. Oops, so I do notice that, oh, it's just the host name. I'll be able to rename it. There we go. Perfect. Okay, but it did somehow get the correct host name. Let's see if router 4 has a different host name. Nope, that one was right. So I'm not sure what happened with router 3, but it is reconfigured. Perfect. So I did finish it before the time of my lunch break expired. That's good news. I'll skip down to the verification steps. Okay, so here's the verification. The first step is going to be verifying the bypass RSVP LSP path. So the action will be on router 0, and it's going to be show route tail. I'm pretty sure they mean table. That's not worth a downvote. Let's do that. Okay, so we've got 19 routes. That's interesting. They've only got 17. But it looks at first glance to be decent. Aha, so we do have a bypass LSP. Perfect. So, yep, everything seems to be fine. It looks a little bit different. Ah, I see. It looks different because of how I have it formatted. If I were to... Yep, so now it looks the same. We've got a bypass LSP, label switch path. Yeah, perfect. Okay, so yeah, that looks good. So when the R0, R1 link goes down, the RSVP bypass LSP is used to route the traffic. So, all right. So the next verification step will be from operational mode. We're going to run this command. Oops, and it looks like they're going to use label 300,000, but that might not necessarily be the label that I'm using. I believe they are assigned at random. So it looks like they're going to be using the one that's the next hop to 30.10.10 via GE2. So let's see. So it looks like this one here is the one that they're going to be using. So for me, that's label 23. Yeah. Perfect. Okay, yeah, so it's going to be labeled 23 for me. and this label is bound to reach router 4, which is a leaf node. Okay, so I think that's it. I've only got like 5 minutes left, so I'm gonna use that time wisely and see if I can get a like traceroute command going, and then shut down that link and see that the bypass LSP takes over. So let's do traceroute MPLS, and then we'll do LDP, and then we'll do a IP address and prefix length. So we'll trace route to router 4. Okay, and we're going to do show MPLS LSP. Okay, so we've got one. Now we've got an ingress. We don't have a egress, which is kind of surprising. We have an ingress here as well. Okay, so yeah, so here's what we'll trace route to. So trace route MPLS, LDP, and then to here. Perfect. So it looks like it's working. Aha! So we found it. It used the. So it looks like there were one path via. Okay. All right. Well, let's see how this is different when I shut down an interface on R0. Okay, and the interface I need to shut down, let me turn on my labeling. It's going to be interface 1, I believe. We'll try both of them. I think I have time for that. Okay, let's see how these differ. Okay, I don't see any difference at all. So let's try the other one. And it's going to be port 2. So no difference there either. I don't know if I'm just not using the right command or what's going on. Let's see, show configuration, pipe display set, pipe no more. Let's see what happens if I do it to one of these addresses, the traceroute command. Okay, so we got a probe status of unhelpful. Okay, so this looks more like what I was trying to get. We've got multiple hops on the way, so yeah, we can see it went through through one path. So let's try the same thing. Now we've got this disabled, so let's bring that back up. So roll back 1, commit, and then see how this trace route changes. So before we had, we got to a TTL of 4. Let's see if we can get a different TTL. And we should have an extra, we should get to a TTL of 5 if it's, or we should be down to a TTL of, to a lower TTL. It looks all the same, so let's try one more thing. We're gonna reapply this. So first we're going to do a rollback 1, commit, and then we're going to reapply that and do a commit. All right. Oops, so now we don't even have an entry at all, so that's interesting. Let's roll back that, get back to kind of a blank slate. So, oops, I did a rollback 0, not a rollback 1. Okay, so we're back to more of a blank slate now. I'm surprised there's no entry for it after that. I'm really surprised by that. Okay, so let's do a show configuration. Yep, all the. Oh, so it looks like I still have this shut down. So yep, I've got enough time to do one more. We're gonna have this go through, and then afterward, I'm going to delete this. Yeah, I just had my configuration mixed up. Okay, so we've got a TTL of 4, so let's commit and quit. And now that this link is up, I think it's no longer going to be using this bypass LSP, so it should have a TTL of 3. And if that's not the case, well, I'll have to move on. So yeah, I guess I'm not sure why that happened, but we can see it did have a different address on TTL3, so it did choose a different path. Alright, so that's it for this video. I think I'm just gonna keep this down to one topic. I'm really moving too slow, so that's gonna be it for this entire topic, LDP no protection. So thanks for watching, and I'll see you in the next video where we go over LFA.